Okay, today we are going to be learning about calorimetry, which is the process of measuring heat based on observing the temperature change when a system absorbs or gives off, discharges energy as heat. You may notice that calorimetry looks a little similar to the word calorie, because when we look at our food and we look at how many calories are in it, that is how much energy your body can possibly absorb from that food. So what we're going to be focusing on is heat and temperature change. And what we have here is a calorimeter. So this is your calorimeter. And that is a tool that we can measure this change in temperature. So whether or not it's absorbing heat, and so that would be an endothermic reaction, or giving off heat, discharging heat. That's an exothermic reaction. So inside this calorimeter, you're going to have a reaction taking place in here, and depending upon what that reaction is doing, the temperature change will be measured by the thermometer. We have it insulated because we're trying to keep this a closed system, so the outside is not being affected or affecting the reaction that's going on. So when we talk about heat exchange, we can talk about the system. So this is the system. Excuse the handwriting. And then surrounding it is our surroundings. And again, excuse the handwriting. So the system is where the reaction is taking place. The surroundings is the surroundings around it, whether or not it's going to give off or absorb energy. All right. So let's take a look at some more important terms. So one of those terms, I'm going to take the definition of calorimetry, put that away. I'll try to. So we're going to take a look at law of conservation of energy. So law of conservation of energy. Energy cannot be created or destroyed. Whatever is lost to the system must therefore be gained by the surroundings. So if the system is giving off heat, it is not disappearing, it is going to the surroundings. Or if the system is absorbing heat, it is not just making it on its own, it must be absorbing it from the surroundings. So that's the law of conservation of energy, and that is important. All right, let's now take a look at the definition of heat. So heat is the energy, the total amount of thermal energy contained in a sample of matter, and we're going to either measure it in calories or joules. Now these calories are not exactly the same as the calories in your food. Actually, the calories in your food are kilocalories, and joules we will be seeing as well, and you might see kilojoules. So those are the units for heat. All right, then we've got ourselves temperature. So temperature, remember when we talked about the temperature in gases, we used Kelvin because we wanted to talk about kinetic energy. Well, here we can use Kelvin or Celsius because we're looking at change in temperature, and Kelvin and Celsius, all their degrees change by the same amount. So we can use either in these problems. So the temperature is the average kinetic energy of molecules in a sample of matter. All right, then we have what's called heat capacity. So the heat capacity is the amount of heat it takes to raise a system 1 degree Celsius. So if you're heating up water, how much energy must be put in to raise that system 1 degree? And so the unit for heat capacity is joules over degrees Celsius, because joules is the energy, how much energy per 1 degree Celsius. So how much to raise the system. And then what we'll be using with our calorimeter is our specific heat capacity. And this is different because we are now specifically talking about the amount of heat it takes to raise 1 gram of a substance, 1 degree Celsius. So now our unit is joules over grams Celsius. So we're figuring out if you had 1 gram of water, how much energy would it require to raise it 1 degree Celsius. That is the specific heat capacity. So if you need to, you can go back and review those terms. They're also on the notes that I have given you. I just wanted to review them before we get to our math. So this is the equation that you'll be using with calorimetry. Q equals M times Cp times the change in T. So Q is our quantity of heat, so that is our energy that's being exchanged. So joules or calories, depending on the problem. Our mass is M, so that's going to be in grams. And our Cp is the specific heat capacity. So remember, the specific heat capacity is specifically how much energy it takes to raise 1 gram of a substance 1 degree. Okay, so this is an important relationship that helps us figure things out. The other one is our change in temperature. So notice this is change in temperature. So we can use Kelvin or Celsius because they go up by the same scale. So you take your temperature final and subtract your temperature initial to get your change in temperature. And you can plug into this equation. Yay, you're going to be doing algebra again. So depending on what I'm asking for, you are going to be solving for one of these variables. So make sure you understand the unit for each variable and what each variable means, because we will be doing a lab on this and you will be doing problems on it. So let's do a problem. So let's keep our equation over here so we can see it, and let's bring our problem over. Okay, and I think I will erase that. Okay, so the problem that we're going to be working is off of your notes. So you've seen this before, but just in case you want to watch it again, pause and go back, I am going to show you this problem one more time. So we have a sample of water. The sample of water is 466 grams. And we know that we are heating it. It's starting at 8.5 degrees Celsius and going to 74.60 degrees Celsius. What you're trying to calculate is the amount of heat absorbed in kilojoules. And we know that the specific heat of water is 4.184 joules per gram degree Celsius. So our 466 is our M, right? That's our mass. Our first temperature is our T initial. Our final temperature is our T final. And we are looking for heat, so that is Q. That's what we're solving for. And we have our specific heat. Remember, the specific heat capacity is how much energy it takes to raise 1 gram of a substance 1 degree Celsius. So we're not raising 1 degree Celsius, we're actually raising quite a few. So we are going to need more than just that much amount of energy. Plus, look how large our sample is. We have 466 grams. This is how much you need just for 1 gram. So this equation makes sense. It's a bunch of multiplication. So we are solving for Q. So Q equals M times the specific heat capacity times the change in temperature. Let's figure out our change in temperature. That's just a subtraction problem. So 74.6 minus 8.50. And take a moment to do that in your calculator. So you should get a change in temperature, which is 66 degrees. So we're going to say Q is equal to our mass, 466 grams, times our specific heat capacity, 4.184 joules over grams per degree Celsius, times, can't see that, let's see, I'll make it our change in temperature. And so you're going to plug that into your calculator. And you are going to get a very large number, which makes sense. But we want it in kilojoules, not joules. And notice that this is in joules. Well, so you need to know that there are 1,000 joules in 1 kilojoule. So since we are changing our joules to kilojoules, we're going to divide by 1,000. So whatever I got, which is a very large number, let's see here. Oops. 1, 2, 3 sig figs, so 1, 2, 9, and then 3 zeros, 1, 2, 3. We're going to take this and divide by 1,000, and that is going to give us our answer in kilojoules. So our Q is equal to 129 kilojoules. So that is how much energy it takes to raise a 466 gram sample of water 66.1 degrees Celsius. All right, thank you.